Welcome to the headquarters of York University's Rover team. The system's architecture is broken into 4 systems. First off is SSCAS, which stands for Science Sample Capture and Analysis System. The second is the DSS, the Drive and Structure System. The next is RM, the Remote Manipulator. These are all controlled with the Icebox, which stands for the Integrated Communications and Control Electronics.
This year, we've redesigned our Science Sample Capture and Analysis System with specific considerations towards the Martian atmosphere and soil composition. To accomplish this task, we've divided the system into 2 key components: the onboard payload and the in-lab soil analysis. When finding an appropriate dig site, we begin by searching for various geological and environmental factors such as fluvial flows, desert varnish, and the degree of rock cover. These areas may provide the perfect habitat for the survival of extremophile microorganisms. The onboard payload is equipped with pH, moisture, and conductivity probes. We've also included a methane sensor to detect methane gas emissions from potential methanogen microorganisms. However, it's worth considering that these tests only provide confirmations for the conditions needed to support life. The real determining tests happen in lab. Our in-lab tests begin with multi-parameter pH strips to remove any false positives. We continue by analyzing the sample with a spectrometer to determine its relative chemical composition. Finally, we take a look at the sample using a compound microscope, thus providing a visual basis for the conclusion of life.
The Rover chassis is made out of a polycarbonate square piping connected by machined aluminum joints. These parts are modular, which allow for easy repair and assembly. Mounting holes are spaced at regular intervals along the entire chassis, allowing other subsystems to be easily mounted. Using polycarbonate over a full aluminum frame cuts the weight required in half. The suspension system is designed with the modular aspect of the chassis in mind, making manufacturing and repair simple. Having a spring constant of 58.3 newtons per meter, the suspension makes a 28.5 degree angle with the vertical. It is designed such that it absorbs vertical impacts without rotating the wheel, ensuring maximum traction.
Building on previous team experience, this year's approach to the remote manipulation system is to assign reference frames to the links of the kinematic chain, otherwise known as the remote manipulator. By assigning coordinate axes to joints and reducing convolutions of those axes to independently prismatic or revolute transformations, we can process from the ground station and develop a solution to a set of linear equations which solve for the necessary motor rotations to find and interact with an object. This year, the mechanical and software teams will be working closely to abstract depth information from the video feed to provide the desired end effector location for inverse kinematics. The end effector is an open source, under-actuated, 3-finger gripper which will dynamically adapt to varying object structures. This will provide a robust platform for object manipulation.
The Integrated Communications and Control Electronics, also known as the Icebox, is essentially the brain of the rover. It consists of an embedded microcontroller known as BeagleBone Black as its onboard computer. It receives wireless commands through a Linksys router, which is flashed with a protocol known as HSMM, which stands for High-Speed Multimedia Mesh Networking. Another branch of ICE is known as the Inertial Controls, which consists of a pulse width modulation driver that signals the H-bridge motor driver array. The motor driver array also contains current sensors for control feedback.
One branch of Icebox is Sensory Cortex. This relays data which include the system IMU, GPS, and video feedback. We're using 3 H.264 cameras that have built-in encoders which allow us to transfer smaller video files but better video quality. One camera is for robotic arm control. 2 other cameras are mounted for stereo vision, which enables virtual reality via Oculus Rift. These cameras will be accessible by GStreamer pipeline. The GPS module will be accessible using a Python script, which will give us the coordinates of the rover at any given time.